This conference will now be recorded.
So as for myself, Avinash, I am into healthcare IT from past 10 years, and before that I was also into BPO for 2 years. So I was working on various healthcare IT projects, specifically into integrations, where we were integrating
Mm-hmm.
HL7 implementations and CCD implementations within various systems of the hospital, where we use an interface engine, basically an application, or we can call it as an integration tool, using which we will interpret HL7 messages or generate HL7 messages and help enabling communication between two different applications within an hospital environment, within an hospital or with external labs or external any other application systems.
Mm-hmm.
So, throughout this course, we will be going through, this course is divided into two parts. First half would be covering HL7. So, what is HL7, how the name has come, what are the standards of HL7, what are different various message types and all. And second half of the training would be specifically on Mirth, how Mirth integration tool is used in order to generate HL7 messages or interpret HL7 messages specifically. And we'll be also looking a little bit into uh, other message types or message standards like XML and possibly a couple of examples for JSON so that you can understand how powerful Mirth integration tool is and how it can be used further in order to uh, deal with various messaging standards that you might receive from your clients. Okay,
Okay.
so let's quickly jump into the introduction for HL7. Um, So by the end of the session, we will get to know where do you hear this term more frequently and where does this come into picture, and what is the hospital workflow, and what is HL7, why the name has come HL7, and what is an interface, and what is the role of HL7 within an interface, and also we'll look at what is interoperability and what is the HL7 message structure. So we'll go to basic overview of all of these things and also the basic overview of message structure of HL7. Okay.
Okay.
So before jumping into that, let's quickly look at few terminologies which we will come across during this session and also the sessions that are going to come further. So PM is nothing but a practice management system. It's kind of front-end application used by the receptionist in a hospital. As the name suggests, it helps the practice to manage the entire, it helps the hospital to manage the entire practice where they will be able to, where they will be able to join or they will be able to take care of the application in, take care of the hospital by creating appointments or by saving patient data within that application and all of these things. So that is basically used by front-end staff. And
Okay.
then we have EHR. EHR is nothing but electronic health record, which is used specifically by doctors or clinical staff like nurses and all of these. And this application is used to store clinical data like patients, what are the appointments that that a specific patient has, and what all the medications that he has been going through, what are the diagnoses that he has been diagnosed with, and all of these things will be stored within EHR. And then HI is nothing but hospital information system, the entire ecosystem of hospital where we deal with different PMs, different EHRs, and different labs. That is called as hospital information system. And when we embed or when we talk about the ecosystem where a lab is also involved between EHR and laboratory, then that ecosystem is called as lab information system. And then we have ICD. ICD is nothing but International Classification of Diagnosis Diseases, uh, which means there is a standard. There is a standard, and there is a classification, and there is a classification, and there is a classification of diseases, which means there is a standard, and there is a classification, 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 and there is a classification which is followed throughout the world in order to classify the diseases. Like fever has a code, and typhoid or malaria has a different code. So all of the diseases that are present all over the world have different codes, and each of them are unique to them, and they can be used to represent a specific disease. So these coding systems will be used. Um, I think you better know, as you have done medical coding. I think you're
Yes,
already aware of diagnosis codes. So this is used by all the applications to identify different diseases, and also these are very much helpful in generating claims and submitting claims with the insurance companies and all. And then we have CPT. CPT is nothing but current procedural terminology. So these are the procedure codes that are applied. For example, in case if a patient is diagnosed with a certain disease, they will apply some procedures like giving an injection or giving some
yes,
medicines. So these are called as procedures that doctors will perform on the patients. So each procedure will have its own unique code. So those are called as CPT codes. And CCD is nothing but continuity of care document. This is nothing but a document which has entire information about a patient, like uh, what are the medications that the patient has been going through, and if he has any active medications or not, if he has any past allergies, or if he has, and what are his current vitals. If he is staying in the hospital, I mean, like if he is an inpatient, there will be details about what are his vitals for specific duration of time. So it is nothing but a document which will give you the clinical history of a patient, if he is an inpatient or an outpatient, anything. HIE is nothing but health information exchange. So health information exchange is also an ecosystem where multiple hospitals are connected with each other with the help of one application, which is called as HIE application. So we'll look at HIE application more towards the end of the session after completing Mirth sessions. And I'll give you a slight overview of how HIE works apart from HL7 and Mirth as well. And then
okay,
IHE, integrating health enterprise. So integrating health enterprise is another standard altogether with like HL7, where using those standards we will form an HI. So in order to communicate or in order to integrate with an HI, you need to follow the IHE standards. So I will also give a little overview about that as well. What is IHE and what are the standards that you have, and I will show you a couple of messages as well when I'll show you a couple of CCD messages as well, so that you can just have a slight overview of what CCD is, what HI, and all of these about these ecosystems are all about. Okay.
okay.
Any questions here?
So yeah, a small question. Like, you are saying CCD, right? I mean, continuation of
Right.
care document. In that, like, the patient might have many records like discharge summary,
Right.
uh, uh, and like if he has a surgery, so he will be having some surgical report and that, like what are
Correct.
the post-operative diagnosis, what are,
Right.
so everything comes under CCD, right?
CCD is one specific document. So there are CCDs can be generated in two different instances. One is appointment-based CCD, another one is patient-based CCD. Patient-based CCD will have his entire history. Like you said, all the procedures that has been performed on patient will be present in that CCD. But when we talk about a CCD from an appointment perspective, it will only have information specific to that particular appointment. For example, let's say patient has been admitted to the hospital twice in the past 15 days. Okay.
Okay.
So for the first instance, he has been in hospital for 3 days, and the second instance, he has been in hospital for 5 days. So first
Mhm.
instance will have a different CCD, second instance will have a different CCD, and the data within those CCDs will be specific to those instances of inpatient that he had at the hospital.
Okay.
That is appointment specific CCD. But when we talk about an overall patient specific CCD, then it will have entire information, including appointments of both the first instance as well as second instance.
Mhm. Okay.
Okay.
Yeah.
Yeah. So I think we have another trainee joining. Hey Jagdish, how are you?
Hey, hi.
Hey,
I'm good. I'm sorry to join late. Like I was, I was thinking about 9:30 Central Time.
Jagdish, your voice is too low.
You able to get me?
Yeah, yeah, that's better. So welcome, Jagdish. So I just started about what are the general terms that we come across while we go
Mm-hmm.
through this training and all. So can you give us brief introduction about yourself and what exactly you are looking for through this training and why you are aspiring to take HL7 training?
Um, I've been I've been staying in US for the last 6 years. Like I've been working in different sectors. Like I completed my graduation in chemistry. Like I finished my master's in India with pharmaceutical chemistry, and then worked for some pharmaceutical company down there in like South India, and then I moved to US and I
Mhm,
finished my chemistry. I worked for laboratory kind of stuff, including it regulatory
mhm,
affairs stuff. And then further, I was interested in getting the administration,
mhm.
uh, and now I'm switching from my regular regulatory affairs to get into this administrative kind of stuff. So I'm just thinking to give a switch in my career.
Okay, okay.
Looking
So,
forward for this.
mhm. All right, no problem. Sounds good. All right, so a little bit about myself, Jadish. So I've been working in this healthcare in IT industry for the past 10 years. So I've been involved in integrating many different systems like PM, EHR, and also HIEs. So where we'll be integrating different applications using standards like HL7, CCDs, X12, and all of these things. So as
Okay.
part this training, we'll be having two parts. First part would be covering HL7, and the second part would be covering how we generate HL7 messages using an application or a tool called as Mirth integration engine, which is a freeware. And we will be
Okay.
seeing how we deal with the real-time HL7 message transactions, how real-time live projects will go through, and I will explain various topics in detail about Mirth integration engine and also how we generate transformations and how we convert different HL7 messages into different message types, and all of these things will be covered. So any questions you have before we proceed further?
Nothing as of now.
Okay. Okay, great. Let me know if you have any questions. We'll take them up. Okay.
Sure. Sure. Sure.
So we'll jump into the next slide. So we'll look at hospital workflow. The reason why I cover hospital workflow for as the basic session is whatever we are
Dixon,
going to. Yes, Avinash.
I can't see the slide.
Oh, I'm so sorry. I'm so
You
sorry.
didn't share it.
Oh, I think I started sharing. So can you see it now?
Uh, no, just 1 second.
It says sharing is enabled, and I'm in audience view. I am seeing the slide.
Yes, I can see the hospital workflow. Yeah.
Yeah, right. Jagdish, can you see?
Yes, I do see.
Okay, perfect. Oh, sorry about that, guys. So we have covered these terms. What is PM, EHR, HISLIS, and all of these things. So I'll be jumping into the next slide now. So the reason why I cover hospital workflow is we whatever we are going to learn will always refer back to hospital workflow, and which is entirely in dealing with the ecosystem within a hospital and also with some laboratories. So we'll quickly go through a slight introduction on what happens in the hospital and how they deal with the data within hospital. And over the course, we'll be referring back many a times back to the this blueprint or this hospital workflow, to understand the live scenarios better on how HL7 messages are interpreted. So we know that once we get to the hospital, first thing is that we deal with the receptionist and or the front desk manager, whoever it is, and they will ask us for our specific details, like if it is the first time that we are visiting the hospital, and they will also take the basic details like what is our name, where are we coming from, address, and all of these things, and if we have some insurances and all of this data is captured, and basically they save this data in the PM application. And this data which is dealt which is captured at the front end by the receptionist is called as demographic data, which includes patient's name, date of birth, gender, SSN, address, insurance information, and all of these things. So whenever they save the data, after saving, then they will go ahead and ask the patient if what are they here for. I mean, which doctor's appointment they are here for, and they will schedule an appointment for that specific patient, and those appointments will be sent to the doctor's desk. And at the doctor's desk, you will have another application called as EHR, and doctor will go ahead and look into that EHR application to figure out what all the appointments he has for that specific day. And based on that, he will go ahead and look at the patients one by one. Okay. And when he is looking for a specific patient, now whenever a doctor meets and patient, that particular scenario is called as an encounter. So we'll refer to appointments as encounter down the line. Either we can say it is appointment or as an encounter. In healthcare terminology, we often represent an appointment as an encounter. Okay. So during this encounter, doctor will go ahead and check the patient. He will try to diagnose what is wrong with the patient's health. And once he diagnoses, he will go ahead and proceed with his procedures or treatment that he has to perform. In case if there is a scenario where the doctor cannot determine just by looking at the patient, then they will order specific tests like urine test or blood test and all of these things. And once an order is placed, that order will be sent to the laboratory. Okay. And this will also pass on electronically from EHR application to the lab, and lab then the patient visits the lab. At the labs, and lab will go ahead and perform certain tests that as per the orders that they received from the hospital, and they will send back the results to the EHR, which is nothing but the doctor's application back again. And patient goes back to the doctor, and based on the result that has been provided, doctor will perform the final diagnosis and then apply the procedures on whatever medication he has to go through, the patient has to go through, that will be provided, and patient can leave the hospital. So once this encounter is closed, once the appointment is done from doctor's perspective, then that is when the charges are generated from EHR application as well as from the lab application, and these charge information will be sent back to the receptionist so that receptionist can get the amount either from the patient or generate claims and submit the claims to the insurance companies in order to get the amount back from insurance companies. Okay, so there are two different methods altogether. So apparently we are seeing here, this is an entire workflow where patient comes to the hospital and patient leaves the hospital, and what happens within this time frame. We have series of events that are flowing on. So we'll be referring back to the hospital workflow many times, as I said, when we are going through the next sessions about HL7 and how we deal with different events of HL7 down the line. Okay, any questions here?
Nothing.
Okay, great. So we will jump to the next slide. So we were seeing that within this hospital workflow, messages were flowing from PM to EHR. I mean, information is flowing from PM to EHR and from EHR to lab. All of these things are done with the help of an interface. An interface is nothing but a bridge, a simple bridge which will connect two different applications like PM and EHR in our case. So just now we saw that whenever a patient visits the hospital, first his demographic information is captured. As soon as that is captured, that information will flow over to EHR. Okay, and when an appointment is scheduled in PM system, that appointment will be flowing over to EHR. This mechanism of flowing of data from one system to the another system happens through the interface. So that is where the HL7 will come into picture. We'll look at how HL7 has enabled communication between these applications in few minutes. But in order to understand what is an interface, it is just a bridge which will be communicating two different, which will be helping for the communication between two different applications. Okay. So before looking at how HL7 and how HL7 has come into picture, let's quickly look at a sample example. Okay, let's say we have three different people from three different countries, like a person from US and person B from India, person C from China. Okay, and three of them know their own regional languages, like US guy knows English and Indian guy knows Hindi, whereas Chinese guy knows Chinese. So these three people cannot communicate with each other, obviously, because they don't know the language that, I mean, they don't have a common language, and at the same time, they don't know uh, the other language of the other guy. So in order for the Indian guy to communicate with the Chinese guy, he has to learn Chinese. At the same time, if he wants to communicate with the US guy, he has to learn English. So Indian guy will be ending up in learning two different languages. And the same applies for the other two people as well. If the US guy has to communicate with Indian and Chinese, he has to learn Hindi and Chinese. So in this way, in case, so we are seeing here with an example of two people. But in case if we have three different people or four different people from different countries, they should end up in learning, for each one of them within that network has to end up in learning multiple languages, right? So they have come up with an idea that we will follow one common language. So English has been selected as the common language, and each one of them will learn just one language, English, and that has become the common language of communication. So the advantages of this are all of them do not need to learn many other languages, they just need to understand and learn one language, which is the common language, English. Okay. So that is one example which we can use here to understand why HL7 is better and why HL7 has enabled common medium of communication between different applications. So let's quickly take a look at our scenario now. So practice management system is the front-end application, as we have seen. It is the application used by hospitals. Front-end management to manage the patient demographic data or appointments. So that being a different application altogether, it will have its own database where the data is stored within that database. And when we talk about EHR is a different application altogether, and it has its own database again, right? And then we have laboratory. So labs again will have their own different databases. So in order for the practice management to send data to the EHR, what exactly happens is, for the data to travel from PM to EHR, data will be extracted from the database, and that has to be inserted into the electronic health record. For instance, if a patient data is recorded within the practice management, all of the data like first name, last name, date of birth, gender has to be sent over to the electronic health record, and that particular database has to be accessed and data has to be inserted. So for that to perform, for an interface engineer or any software engineer, the software engineer has to understand very well about the practice management database, and he should also understand very well about the architecture of the EHR database as well. So as we are dealing with two different databases here, they have to they will take time, and they have to understand very well about these two databases, which will consume a lot of time. And by the time we complete the integration successfully, the project lives will be too high, and complications will also be high because of the different architectures of the database. And if the architecture is not understood properly, that will mess up the entire system altogether. Okay, so in the same way, in case if the practice management or the HR has to deal with the lab database, again they have to end up in learning. Again, the same software engineer has to end up learning the database architecture of lab information system. So here we are seeing about three different applications. But when we talk about real time, we will see that there are many applications which integrate with each other. And if one person starts learning about each one of these databases, then completing one integration itself will take a lot of time, and it will be very hard to communicate with each other. So which is why HL7 has emerged as a common language, like as we have seen in our example. English has emerged as a common language of communication. So HL7 has been emerged as common language of communication. So what happens here is, practice management will extract the data and convert the data into HL7 and will send it over. So message or once the message is generated from the PM application and converted into HL7, that HL7 message will be sent over to EHR, and practice management's work is done. They won't bother on how EHR is interpreting that message, because EHR also should know HL7 to grab the HL7 message and insert the data into the database. In this way, when as HL7 has become the common medium of communication, the PM application or the HR application, even if they are two different entities, all that they need to understand is HL7 language or HL7 messaging standard. Once they understand that, they don't need to understand the architectures of the database of each other. They just need to understand the HL7 message, and once they understand the HL7 message, they can easily interpret it. Similar to the scenario that we discussed, where if the other person understands English, then that's well and fine. He doesn't need to go ahead and learn other language of the other guy. In a similar way, the applications do not need to understand each other database architecture. They just need to understand the HL7 language. So we will see uh, how HL7 standards are developed, how HL7 has been uh, created, how HL7 message has been created in next few slides. So, so HL7 is nothing but common medium of communication, as I said. So it is used by many organizations where integration of data is the primary goal, and where data is shared between two different applications. And the name itself is used very much in healthcare computers to enable talking of two different applications altogether. And there are more than 28 countries who are using HL7 so far. Not very much established in other countries, but it is very robust in US, where they will use a lot. Many of the hospitals will use HL7 as the common medium of communication. Apart from US, there are other countries like India, Australia, UK, South Africa, and there are some UAE countries like Iran, and Dubai, and all of these things. So they are very well using HL7, but not as established as it in US. So now let's take a look at why the name HL7 has come. So to understand that, we need to understand the OSI model. OSI is nothing but operating system interconnect model. So this is the basics of how the data which we see at the front end is actually communicating with the is actually passing through the network and communicating with the other people. Okay, for example, for instance, I am talking here now and I am presenting something on my screen, but you are able to see it on your screen. So how is that possible? Basically, whatever I am showing here is being converted to packets into a physical form and is passing through the wire that I have. A hard code, a hard wire, which is a physical substance, and those packets are being traveled through the network and reaching you, and you are able to see that whatever I am presenting on my screen on your screen. So that follows a specific model called as OSI model, where we have 7 layers. So the first layer is called as the application layer, which is nothing but the general screen or the general application that we are seeing it. But behind this, behind the application layer, there are 6 more layers which will enable communication of data from one system to the another system. Okay, so other 6 layers are presentation, session, transport, network, data link, and physical layer. So the data which I am showing here on the front end will pass through all of these layers and finally will be converted to packets. And those packets will be sent over through the internet hard cable wire, and that will pass on through the network and will reach the destination. In our case, it's you who is seeing my screen. So this enables the communication. You can research more on OSI model if you don't have an idea on that. But the reason we look at OSI model is the HL7 messages that are going to be generated. All of these things, all of that operation will be done within the application layer of the OSI model, which is the 7th layer. So which is why we name it as HL7, health level 7. Okay, so you can research more on this. It is really interesting to understand how the data is actually transmitting through the internet and all. Okay, any questions till now?
No, go ahead, please.
No, Dixon.
Okay, great. So next we will see the overview. Like any other language or standard, HL7 has its own grammar and syntax. So we'll look at that when we start understanding the structure of HL7. We'll take a look at what is the grammar and syntax that we use, and it has version
Mirth
2.3
uses
has.
JavaScript. I'm sorry to interrupt. I think Mirth uses JavaScript language.
Yes, Mirth
Uh,
uses JavaScript.
oh, okay, okay.
So we'll take a look at that. Um, yeah, so version 2.3 has 12 chapters and there are 5 appendices. So we'll be going through few of them. Apart from 2.3, we also have 2.5, 2.7, which is robustly being used in the industry at this point. And these have more than 50 data types. And we'll be looking at almost 35-40 data types, which are very, very important. And we'll be also covering the most frequently used message types in the industry. But there are apparently more than 80 message types within HL7. and there are more than 86 event types. So we'll be looking at almost 10 to 12 message types which are frequently used within the hospital industry, and also the event types associated with them. So just to quickly look at HL7 history. So it has been in industry from 1980s itself, but the standard has been emerged in 1997, where the first standard was 2.3, which is approved and vastly accepted by the entire hospital industry. And from then on, we had different versions. Currently, the version is number 3, but 3 is the grammar and syntax and architecture of 3 is completely different from what we have in 2.3, 5, and 7, which is why 3 is not very much vastly accepted. We still see that we still see that hospitals are using 2.5, 2.7, 2.3 as their standards for its ease of use and ease of understanding. Version 3 is a little complicated, so people are not using it much, and it's like Windows 8, which is not accepted much by the uh, technology people. So, and then we have FHIR. FHIR is Fast Health Interoperability Resource. So this is another standard released by HL7. This standard is used specifically to deal with APIs and resources in the form of XML and JSON. So we will not be covering FHIR standards through our training. We'll be just covering HL7 standards. FHIR standards are completely different again. They are used much with integrating mobile devices and integrating wearable technologies and all of these things. So let's look at what are the advantages of HL7. So it will enable the ability to share data, which is demographic, billing, and clinical data between different HL7 enabled applications. So data transfer will be in the form of messages, which is like events. We'll look at what are events and how each message is generated for each event whenever in our next sessions when we are talking about HL7 message types and standards and all. So we don't need specific tools for creating messages. We just need to understand about integration engine, and the code is in ASCII format, which means if you understand the standard, you will be able to understand what is currently present in HL7 message. So you will be able to just read what is the data that you have. So it's easy, and it is independent of OS. It can work on any OS. It doesn't matter. It can work on Linux, it can work on Unix, because of the fact that it is mainly operated on an application layer. Each OS has its own application layer. Linux has its own, Windows has its own, Apple has its own. So as it is operated at the application level, it is completely independent of OS, and NHS message can be generated or interpreted. And it can connect from any application to any application. As we have seen, we don't the when we talk about integrating two different applications, each other do not need to understand their the architecture of other database. They just need to generate HL7 messages and send it over, and the other person who is receiving it should be able to interpret HL7 and insert the data into database. So apparently no much learning about other systems, which will enable connecting of uh, any system to any system apparently. And HL7 offers access to the overseas market. So basically, this has enabled communication between different countries as well, and market is very huge. Like many people are learning HL7 and running with implementations using HL7 standards across various countries. Okay, and why do we need a standard? So sharing of medical data is very critical, and we cannot have any format of the message just like that to transfer medical data from one system to another system. So to make sure that data is transferred accurately and in the proper format, we have come up with a standard which is HL7 standard. And it will this will enable for accessibility to larger set of data, like when we talk about patient's order information and or patient results information. It will help us to expose ourselves to larger set of data from a broader perspective, like what is the result all about and all of these things. And this being electronical, patient data being transmitted electronically between all of these systems like PM, EHR, and lab, this will enable quicker claim payments or quicker claim generations from the applications where the manual work is very low. Now, in India, we see that we are still on manual phase in generating claims and sending it to the insurance companies, calling them and dealing with them. But in the US, we see that all of the claims are generated electronically, and that is way more faster than what we do manually here in India. And interoperability is nothing but the power of applications to talk with each other, which is generally enabled with the help of integration engines. So apps can talk to each other because of this particular HL7 standard. And at the end of the day, greater safety for the patient as data is transacted in a systematic format, and the scope of error in transferring the data or transferring the incorrect data is very less, which will enable greater safety for the patients. And accreditation, as I said, HL7 standards are organized and maintained by HL7 organization, so it is always accredited by a specific uh, authority, which is HL7 org. So we don't need to much worry about uh, whether it's a correct format or not, or whether it's a safe format of the messaging standard to use or not. And at the end of the day, above all of these things, the quality is a lot because HL7 has minimum to minimum errors when we implement it properly in order to transfer data from one system to the other. And obviously, the market is very, very big. So let's look at how HL7 messaging works. So it basically works on trigger events. So we'll see what trigger events are. Before that, we'll try to understand what are events and what are trigger events. So now we'll refer back to the hospital workflow again. So when we're talking about hospital workflow, we have seen that whenever patient gets registered at the front end within the hospital practice management system, the patient data, the demographic data will flow from PM to EHR, and the appointment is getting scheduled. And whenever the appointment is scheduled in the PM system, this appointment flows over from PM to EHR. So this requirement, like generating data and sending it over to EHR, so this is happening in the real time. So we are talking about a real time scenario or real time event where the necessity has been raised for the data to transfer from PM system to the EHR system. Because if the patient information is not passing across from PM to EHR system, the doctor wouldn't know the name and details of the patient, first point. And if there is no data flowing over from PM to EHR about the appointments, doctor will not get to know what appointments he has for that specific day. So what I'm saying here is this is a requirement which has generally came into picture, that data should flow from one system to the another system. Okay, which is the result of a real-time event in the world, which is nothing but capturing demographic data or creating appointments within the front-end system. So this standard is written in an assumption that the an event which is happening in the real-time world, like capturing demographic data or capturing appointment data, has generated the necessity of data flow from PM to EHR, or from basically from one system to another system. So that event which is happening at the front end, like capturing demographic or appointment, which is an event, is called as a trigger event, as it is triggering the necessity of data flow from one system to the another system. So trigger event is nothing but, to define it, the real world event where the data has to flow from, or where the need of data to flow from one system to another system is generated. That particular event is called as a trigger event. For example, as I said, capturing demographic data and sending that demographic data from PM system to EHR system. This is an event. So that event has generated the necessity of data flow of the demographic information from PM to EHR. And for another instance, we can take that whenever doctor places an order, so that's considered as an event, and doctor will go ahead and place an order within EHR system. If it is residing within EHR system, there is no use, because lab will not get to know what is the order that has been placed. So there will be an interface, and this will enable the communication between hospital and lab, and the data will be sent over from EHR to laboratory. So this has again generated the necessity of data flow, which is nothing but placing an order, which is an event, has generated the necessity of flowing of this order from EHR system to the lab system. So this entire thing is considered again as another event altogether. So in this way, each of these events are called as trigger events. So we will see what are the possible events that we will go through within the hospital workflow. But basically, HL7 messaging standard works on events. So it is an event-driven messaging standard. Here, so we'll quickly look at what are the trigger events that we will come across within a hospital's workflow. So patient gets registered at the receptionist desk. So the primary head, or the on a broader view, we can say that registration is one event, and then appointment is scheduled. Appointment is called as another event, and then we have labs. Labs are nothing but the orders which are being placed by the doctor to the laboratory. So on a broader note, that is called as another event. And once all of these things are done, they will send out the insurance claims and charges. Those are different events again. And then we have pharmacies, communication with pharmacies and insurance companies, which are dealt as different events altogether. But apparently, we are seeing that registration, appointments, labs, and charges. So we'll be dealing with all these four different types of events, and what are the different message types, and what are the different event types that we'll come across within these events and all. So any questions still here?
No, Dixon.
I'm good. I'm good.
Okay, great. So let us quickly look at the anatomy of the messages. So just to understand a slight overview of what HL7 and how HL7 message structures are generated. Okay. So before looking at that, let's take a small example, like like there is a rack, where in the first rack you are storing clothes, and in the second rack you are storing books, and third rack is even in third rack you are storing the books. And within first rack, in the first compartment of that first rack, you are storing t-shirts, and in the second rack you are storing trousers, and in the third rack you are storing shirts. So this is a generic example that I chose for helping you understand better of what HL7 is. So let us quickly take an example. Let us say there are three different people staying in a house, and there is a rack in the house with this particular design or architecture. Now, one of the person has gone out, and he says the other person at home that, hey, can you get me that t-shirt or trouser? Then the person who is at home will go ahead, pick that t-shirt or trouser, and he'll go and give the trouser or t-shirt to the second person. Here, if we deeply look at the communication between these two people, the person who is outside the home will call the person at home and he will just tell that, can you get me the t-shirt? Can you get me that green color t-shirt or something? He will give the specifics of t-shirts, but he doesn't give the specifics of location of where the t-shirt is. Okay. Reason being, people who are at home already know that where the exact location of this t-shirt is. He doesn't need to guide the other person who is at home that you go check in the first rack and first compartment of first rack and get that t-shirt and all. He doesn't give the address or location of that specific t-shirt where it is located. Okay. In the same way, in case if he has to get some book, he will just communicate about the book name, but he doesn't communicate about the location of the book, because everyone at home knows the location of that particular element or entity. Okay. So this is HL7 is very similar to this, knowing where goes what. So understanding which data element in the real-time world passes on to which specific location within an HL7 message is all about HL7 standard. Okay. Let's say if you have power off at your home. Okay. What is the first thing that we do? We just go ahead and try to search for a candle. And even if we don't have the power, we will navigate to that specific location where the candle is stored. We'll pick the candle and we'll lit it up, even if we are unable to see it, because of the fact that we know the location. In every house we have a specific location for these kind of things like keys and candles and all of these things. So we don't need to go ahead and search for it. We just know that it is located at specific location and we just go and grab it. So HL7 is also very similar to that thing. So we'll take a look at the anatomy of the HL7 message, and then we will compare back the HL7 message to this particular rack architecture. So each HL7 message has many segments, and each segment has fields, and each field has components, and each component has subcomponents. What do we mean by this? This is like a tree kind of architecture. So once we look at the sample, we will understand that better. So each HL7 message, as I said, will have its own segments, and each segment will again have its own fields. So each segment can be compared to one rack within the rack that we have seen, and each field can be compared to one compartment that we have seen. So first compartment, second compartment, third compartment, and so on. So when we see an HL message, it will be in this way. The first compartment represents certain kind of data. For example, let's talk about patient information. So first compartment will completely have patient information. Not compartment, I'm sorry. First segment will have complete patient information like patient name, last name, date of birth, gender, SSN. So there are many data components or data elements that we are talking about, like patient first name, last name, date of birth, gender, SSN, and insurance. Not insurance, but the address, phone number, email address, and all of these things. So everything will be stored within the first rack, or one rack can be compared to one segment, and all of these data elements which are related to demographics or which are related specifically to patient are stored within first segment of HL7 message. And within those segments, we are again dividing that segments into different compartments which are called as fields, so that each compartment can hold specific type of data. Like like first compartment will hold, I'm just giving an example, this is not the ideal location, I'm just giving an example. So first compartment will hold patient name, second compartment will hold patient date of birth, third compartment will hold patient address, and fourth will hold patient SSN, and so on. So in this way, HL7 messaging structure has been designed to hold all the different types of data elements that we captured in the front end when a patient is being registered. Okay, so when we are registering, they capture all the different types of data elements, like each data element, like last name, first name, middle name, and email address, phone number. So there is specific placeholders within HL7 message in the form of compartments or fields, where these all of these data elements that are being captured in the front end will be stored. Okay, and again each field is again divided into subcomponents. So for instance, if I say that first field is holding the name information, it will again have two components within that particular compartment or particular field, where the name is again can be broken down into two data elements. One is last name and the other one is first name. So within first field or first compartment, I would say we'll have name, and that name has again two components. First component is last name and second component is first name. So again field is again broken down into two components, that is last name and first name. Again within fields, within components are again broken down into subcomponents. So we'll look at examples to understand this better. For now, understanding till components is good. Okay. To summarize this, an HL7 message will have segments, and each segment will have fields, and each field will have components. Components will again have subcomponents. We'll look at subcomponents part later with an example, but for now we need to just understand that there are four major things within a message and its segments and its fields and components. Okay, let's look at what is the grammar within HL7 message. Okay, so there are specific grammatical syntax that we have to follow in order to interpret an HL7 message or to read an HL7 message. So let us say like we have full stops, we have commas, and we have exclamation mark within an English language. In the same way, in within HL7 we have its own syntaxes that has to be followed in order to understand an HL7 message or read an HL7 message better. Okay, so there are six of them. We'll take a look at that. First one is segment terminator. It's kind of a full stop. So at the end of each sentence, we put a full stop in English language. In the same way, at the end of each segment, we will ensure that there is a carriage return segment terminator, which is called as segment terminator, so that whenever we are sending the data to the other system, we will put a segment terminator at the end so that the receiving system will understand that one single segment has been terminated or completed. And then we have field separator. As we have seen in the previous slide, each compartment has to be, or each field has to be separated from each other, right? We cannot club everything in the say. So to that happen, there is a separator called as field separator. This is called as a pipe we are seeing on the screen. So this will help us to differentiate two compartments or two fields altogether. Okay, and then we have component separator. So within a field, we will have a component separator called as caret. So this is the cap symbol that we are seeing here. So if you talk about last name and first name, so last name and first name are separated with the help of this caret symbol. And then we have subcomponent separator. So within a field, within a component, if there are two subcomponents, we will separate the two subcomponents with the help of ampersand. We'll take a look at an example with that. And then we have a repetition separator. A repetition in the sense, for example, let's say there is a field which is dedicated for phone number, and that field can have multiple phone numbers. For example, they can have two phone numbers. A patient might have two phone numbers. So those two phone numbers are held within that specific field. However, these two phone numbers will be separated with a repetition separator called as tilde, which is kind of inverted S. So whenever we look at that, we understand that this is a repeating data element, which means the same data element has been represented twice within one field. Okay, we'll take a look at an example for that as well. And then we have escape character, which is nothing but uh, which is kind of used in other traditional languages as well. So whenever you have a backward slash, whatever is present soon after that backward slash will be ignored by the system which is interpreting the HL7 message. So at times we might have some special characters within HL7 message that we want to send, and at the same time we don't want the receiving system to interpret that particular special character that we are sending. So in such instances, we'll send out a backslash so that whatever special character we are sending in the HL7 message will not be interpreted on the other end. Okay, now let's take a very quick look at the sample HL7 message. So this is an HL7 message representing the data of patient demographics. So as I said, each HL7 message is divided into segments. So each of these are segments that we are seeing on the screen. MSH is one segment, EVN is one segment. And by the way, each segment will have their own name. Okay. So the first segment, within each segment, the first three values will represent the name of that segment. Okay. Like we see here, MSH is one segment, EVN is one segment, PID is another segment, NK1 is another segment, PU1 is another segment. So we have 5 segments here, and within 5 segments we are having fields, and each field is again divided into components. So let's quickly take it one example to understand it a little bit better. So the third segment that we are seeing is called as PID. PID is nothing but patient identification. Within patient identification, as the name itself suggests, it will have identifying information related to that patient. And if you look at the information here, we have test John, which is nothing but the name of the patient. Okay, so as we see, we have many compartments which are nothing but the fields. So the first field is empty, second field is has some data, third field has some data, fourth field has some data, so fifth field has some data, and we have test John. Okay, so we read it as one. Whenever we read the HL7 message, we read it with the segment name and the field number. So for example, we are saying that the segment name is PID, and we will be numbering each field, and first this is first field, this is second field, and this is third field, this is third field, this is fourth field, and this is fifth field, and so on. So we will look at a tool which will interpret these fields for us in a numbering system. So in further sessions, so that you can understand it better of how to read the NHL7 message. But for now, PID5 is always represented with the help of name. Okay. So within this name, we are seeing that we have components which are divided, which are separated with the help of a component separator. So the first component is called as last name, and the second component is called as first name. Okay, so this is an example to understand a component separator. And we have again PID 13 with the phone number, if you see this one, which is separated with the help of a tilde, kind of inverted S. So the patient has two phone numbers. This is the first phone number and this is the second phone number. So in this way, you can go ahead and read an entire HL7 message. So this is PV1 segment is for patient visit, and PID segment is for patient identification. And then we have a message which is message segment header. So this is the way that you go ahead and read an HL7 message. So do you have any questions so far with the messaging system?
Dixon, can you go to the previous slide?
Yeah, sure. Yeah.
Here, encoding character position, you are saying, right?
Yeah.
Uh, I didn't get that. Like, what is that?
Yeah. So within this HL7 message, in the
Okay.
first MSH segment. So we will talk about this when we come back to HL7. So we will have a detailed session on MSH segment. So we are going to have
Okay.
sessions on each of these segments. So it is representing apparently the position of these encoding characters within an HL7 message. So I will explain that when we talk about MSH segment in a broader manner. So basically
Yeah.
that position is representing what is the position of that particular encoding character within the message.
Okay.
Okay.
Yes.
So any other questions you have?
I mean, in order to get certified, like,
Mhm.
is this training enough, or do I need to buy any other books or any material?
No. So we have that covered in the next slide. So for training, you can study by yourself or through webinars or seminars or by trainings like this. So you need to read all chapters, but you specifically exam will be specifically from chapter 2, which will cover 3 books, chapter 2, chapter 2A and chapter 2B. So it contains 3 different books, and we'll be sharing that material with you. So you don't need to worry about purchasing them and all. So as I've done it already, I have material which we have to go through for HL7 messaging, HL7 certification for 2.7 version, which is currently being organized by HL7 organization. And as I said, certification will be done by the HL7 org, and HL7 messages are regularly held all over the world. But you have to pay for the certification. That is there.
Yes. Like, how much? Like $120 or some.
No, it's $299.
Okay.
It's $299 for non-partners. It is $199 for partners. So few organizations are tying up with HL7 organization. So whoever is already tied up with HL7 organization, for them the certification cost is very low, like $100 less. So if
Mhm.
the company is registered, then you will get it for very less. Else you will get it for you will have to register as an individual, and that will charge you $299.
Mhm. Okay.
Okay. And then who can train in HL7? So basic for understanding basic training of HL7, all the hospital people will usually try to understand, and then programmers in healthcare apps will know HL7, basics of HL7. So and doctors and paramedics and also the IT administrators will know HL7. And intermediate level, basic level can be understood by many people. Intermediate level, specifically programmers of healthcare applications, doctors and paramedics, because they'll be dealing with electronic data, so they need to understand how the messages are passing on, and also by the IT administrator. And with expert level, certainly the programmers in the healthcare industry at an architect level, they need to definitely understand in depth of each of every segment and fields, and also IT domain experts has to understand the HL7 very well. So to summarize it, HL7 is mandatory for interoperability. Without that, there will be no communication between 2 different systems. And also HL7 is fastly becoming a requirement for healthcare standards, healthcare standardization in healthcare applications. So we are seeing that many different countries are using HL7 as their means of communication between 2 different applications. We have hospitals in India as well who are using HL7, like AIMS, Continental, Apollo, and there are certain few other hospitals which are using these standards actively. So apparently, down the line the business will be very high. So and the requirements are also very high, because HL7 is mandatory for communication between different healthcare applications. So that ends our session for today. So do you have any questions, Jagdish and Avinash?
I'm just wondering, like, how long we do take in order to get the certification done?
So certification completely depends on so training or certification, preparing for certification.
Preparing for certification from the
Preparing,
scratch.
okay. So after completing the training, first part of the training, you can start for preparation. It is not
Hmm.
required for you to understand how integration works in order to get certified. You just
Yeah,
need to understand.
I went through your videos, like, I mean, like online reading and something like that. As per what I understand is like you don't need to get like complete interface knowledge, like interface engine
Right,
knowledge in order to get certified. Is that, if I'm not wrong?
right, right. So all that you need to read is all those three books, 2A, 2B, and 2C. Sorry, 2A, and 2B. So
Mhm.
those are around 600 pages.
Okay.
How good you under so we
Hmm.
will cover concepts of how to understand different data types and different messaging standards and different profiles that we implement in real time. But it
Uh-huh.
depends on how good you memorize because HL7 is mostly
Yeah,
about
that's what.
memorizing. So it will take around 30 to 60 days. If you at least read 2 to 3 hours a day, it will take 30 to 60 days for you to
Hmm.
understand completely and go for certification.
Okay. I wonder like how the workflow goes in with the HL7. Like, you'll be the only person in order to take care of that, or you'll be in a team.
No, no. I mean, for the training,
No, I'm saying in the work, like real time work.
in the real-time work, okay.
Yeah.
Okay, when we talk about real-time implementations.
Yes.
So we have seen, right, now in the hospital workflow, this is our entire hospital workflow is divided into events, right?
Yes. Yes.
Demographic
Mm-hmm.
event, appointment
Like
event.
trigger,
So
everyone is trigger
each
based. Yeah.
each project, right, each project implementation will be again specific to events. For example, one project will be for demographic event, one project will be for appointment event. So each person will
Okay.
handle one event type of project. Okay.
Okay.
For example, I am an
Uh-huh.
HL7 engineer. I apparently I should be able to handle all the events, but when we talk specifically from project perspective, there will be a demographic project um, to implement an interface which will communicate demographic messages from PM to EHR or from one application to another. So that will be considered as one project, and within that project, we have to ensure that all the demographic data will be converted into HL7 and will be sent over from our system to the external system. And also, if you are working on the other end, then you should be able to receive that ADT message or basically the demographic message and
Mm-hmm.
interpret that and insert the data into database. So from
Okay.
project perspective, it is event driven.
Okay.
And it might be the case that you will be dealing with multiple events for one single project as well.
Uh,
So yeah,
Interface
any other questions, Jagdish?
regarding to the HL7 as.
Jagdish, your voice is low and
Did you get it?
breaking.
Like, I'm asking, what is the most? Uh, I'm sorry.
What is the most?
Are you getting it?
Yeah, yeah.
I'm saying,
I
what is the
mean,
outmost used interface engine as of now?
so there are many interface engines in the market. There is Mirth, which is a freeware. There is Rhapsody, which is not free, obviously. And there is Iguana, there is E-Link. Mostly used are Mirth and Rhapsody in the market as of now. And Mirth is being freeware. It is even more robustly used in healthcare industries. And Rhapsody is also a very powerful tool. So Rhapsody and Mirth are
Okay.
the most that you hear is about these two. So there are others like
Okay.
Iguana, there is Integration Buddy, there is Connector, there is Ensemble and all. There are many, but These are the two that you most frequently hear.
Okay.
I mean,
So
like, what are the tools we have to install to do this? I mean,
you just have to install HL7, sorry, Mirth integration engine. So
okay,
that's a freeware, that's a free software. So anyone can install it and start working on it. And we also need SQL database. It can be anything, but I prefer Microsoft SQL Server. The free version of Microsoft SQL Server, we can use it, the Express edition. In order to, we need to see how we generate HL7 messages real time. So we'll be having working sessions on how we extract the data from database using Mirth, and how we convert that extracted data into HL7, a real-time HL7 message that we can send across to the destination system. So we'll be looking at all of those things. So the two primary things is um, Mirth integration engine and SQL Server. These two softwares are required. There are other tools like HL7 message reader, which will help us to read an HL7 message to understand what data element we have in each field. So I will share those details with you. Those are also free tools which we can use.
okay. So this will be like very much similar to the real time, right?
Absolutely, yeah.
Okay. Okay, Dixon. So, like, if there are any, I will let you know.
Sure, sure. So Jagdish, are you good? So do you have any other questions?
No, nothing as of now, Srinivas. Thank you.
All right, sure, sure. So further communication can be done through Srinivas. So we'll catch up, and we will, if you guys are ready, then we will proceed with next sessions maybe, and we'll schedule some time starting next week, and we will continue with that. Okay.
Okay, sure.
All right, guys. Thank you.
Sure.
It
Thank
was
you.
nice talking to you. Bye.
Bye, Dixon.
Thanks.